Nothing lasts forever, and so we depart October for the cold November rain. Still, everybody needs some time on secure code, which means this week we speak with Alfred Chung from Signal Sciences about the developer experience for bringing strong app security into Azure App Services. In the news segment, the curtain opens for an encore with Security Theater. The stage is set for data breaches from compromise, cloud, and now code. Previews for links means problems for privacy. The curtain closes on Flash, which I have to throw in a dramatic pause there because finally, wow. And more. Note the exits and stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Application security is hard when security is separated from your DevOps workflow. Security has traditionally been the final hurdle in the development lifecycle. Iterative development workflows can make security a release bottleneck. With GitLab, security is built into the CI/CD process. Every code commit is automatically scanned for security vulnerabilities in your code and its dependencies. Results are delivered to the developer in their native workflow for rapid remediation. Learn how GitLab enables DevSecOps. Visit securityweekly.com/GitLab for a 30-day free trial. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/synopsys to learn more.
Welcome to Application Security Weekly. This is episode 128, which is episode 2 to the 7th, recorded 2 to the November 2020. That mostly works. I'm your host, Mike Shima. The role of co-host will be played by Matt Alderman. Hello, Matt.
Good morning, Mike. Daylight saving time's over, which means lighting will be fun. We'll see where the sun goes today.
We'll see where the sun goes. Speaking of which, the role of other co-host will be played by John Kinsella. Hello, John.
And John Kinsella is happy to report that we still have a sun in 2020, so, we got something good going for us.
We got something good going. Thank you for staying optimistic for us, John. While the sun is up, you have the chance to join Amit Bereket, co-founder and CEO of Perimeter 81, and Paul Asadorian for a technical deep dive into the problems inherent in legacy VPN technology. Together, they will explore solutions for the modern workforce and how momentum toward perimeterless architecture is helping redefine the future of cybersecurity. Register now by visiting securityweekly.com/perimeter81. Would you like to have all of your favorite Security Weekly content at your fingertips? Do you want to hear from Sam and Andrea when we have upcoming webcasts and technical trainings? Have a question for one of our illustrious hosts, someone from the Security Weekly team, or wish you could hang with the Security Weekly crew and community? Subscribe on your favorite podcast catcher, sign up for our mailing list, and join our Discord server to stay in the loop on all things Security Weekly. Visit securityweekly.com/subscribe. Alfred Chung is a senior product manager at Signal Sciences, responsible for modules and the product deployment experience. Prior to Signal Sciences, he worked on various enterprise security products in the endpoint security, vulnerability management, and application security spaces. Hello, Alfred. Thank you for joining us.
Hi, Mike. Glad to be here.
We're glad to have you here. And in fact, we've spoken, we've talked a few times with Signal Sciences, and you're focused on a really interesting angle here, the developer experience, especially in this case, as it pertains to the Azure App Services. But before we get into the Azure App Services itself, tell us a bit about what does it mean actually to focus on developer experience as opposed to, say, just pitching to a security team?
Absolutely. So at Signal Sciences, we have a very developer-centric sort of approach to security. Our founders came up with the idea for Signal Sciences at Etsy, which is, of course, the online sort of marketplace where, and also one of the kind of the leaders in DevOps back in the day. And what the founders saw in the market was, web protection platforms or web application firewalls that simply just couldn't keep up with the rate of change of applications that go through kind of the DevOps process. So when we talk about developer-centric, we mean having security protections for your applications that can be easily deployed by developers and DevOps professionals, and have that protection kind of stay with the application regardless of where it's deployed and regardless of how often it changes or how often it's deployed.
So I'm kind of curious to poke a bit more about that aspect of deployment and developers actually, or the DevOps team actually doing the deployment, doing the management rather than the security team. So does this mean that now the developers have to deal with editing a bunch of text files, whether they're YAML files, et cetera, or can they just work from Visual Studio, for example, if we're talking about Microsoft platform and Azure App Services?
Yeah, absolutely. So a month or two ago, we launched our Azure App Services site extension. So Azure App Services, for those who aren't familiar, is a platform as a service delivered on the Azure cloud. And this enables organizations who perhaps have legacy applications that they've written in Visual Studio to enable them to easily deploy them to the Azure cloud without having to manage an underlying web server or operating system. With the site extension, we've been able to package our Signal Sciences agent as well as our IIS module in a way that allows developers to deploy our web application firewall or next-gen web application firewall on applications and workloads hosted in Azure App Services with essentially a click. So although users of Signal Sciences may previously have had to install the agent themselves or the module themselves, at the command line, the site extension is a really exciting new option for our customers in that it really simplifies the deployment experience and gets them up and running with Signal Sciences more quickly than ever.
So, and I want to also, too, platform as a service is pretty compelling because it basically means that for, as you point out, I think these are possibly more like perhaps legacy enterprise scenarios, but you can deploy into the cloud and actually Azure is going to take care of all of the patching, all of the service maintenance, and you're literally just dropping your code onto a web browser stack. And in this case, now you're saying, you're describing how to put a, Signal Science, a WAF effectively on top of that to protect this legacy code, which, because we're using the magic word legacy, often has connotations for not necessarily the best written code or it's going to have vulnerabilities. But and so I mentioned too, like the Azure App Services can be self-patching, for example, manage it itself. But there's also got to be a lot of sandboxing and other kind of constraints within app services that are actually very good security capabilities, security design. But what did you experience as you're trying to create a security service within app services and trying to work within some of these constraints of the sandboxing, for example?
Oh, yeah. So, Azure App Services, of course, is multi-tenant. So Microsoft has implemented a number of controls to ensure that workloads hosted in app services are secure. And for example, one application environment can't reach out to another application environment and steal or corrupt data. So, these protections, of course, are a great feature for app services customers, but it certainly presented us with a technical challenge in that the way that our agent module architecture works typically requires some callback to the local host to enable communication between our module component, which is typically sitting on the web server, and passing requests to our agent that does all the decisioning and decides whether the request should be blocked or should be allowed to proceed. So because of the sandboxing implemented in the app services environment, there was no clear way for to install an agent and enable that agent module connectivity. The way that our engineering team was able to work with that constraint was essentially improve our module so that it had the ability to start and stop our agent and essentially launch it as a child process. And with that sort of processing or execution of the agent, we were able to avoid the sandboxing constraints.
So that's, to me, that's kind of interesting, hopefully to others too, is that going cloud native, just even more generally speaking, on the one hand is pretty easy at the application layer. This was sort of a lift and shift, if you will, for enterprises running on a .NET. They could just go into app services. But for you to provide that developer experience, to create a more seamless way to actually intercept the traffic, inspect traffic, it actually took you and your team some changes, architecture decisions, changes in code to make that capable. I'm curious too if you've seen that generalize a bit more into other types of cloud native services, whether they are just something Kubernetes in the cloud or even just service meshes, for example, to go sort of the opposite end of the spectrum, if you will, from even just the Azure app services.
Oh, absolutely. So at Signal Sciences, we have customers that kind of range across the entire maturity spectrum when it comes to application development, whether it's large enterprises that are trying to figure out how to protect their legacy applications that perhaps haven't been patched in some time or can't be patched because nobody knows where the source code is, to kind of startups, I guess, that are early adopters of some new technologies like service mesh and perhaps have been running their or using microservices-based architectures for some time. So in terms of developer experience, deployment experience, what I'm really focused on is ensuring that our customers across that maturity spectrum have a great experience when it comes to deploying our technology and is able to deploy Signal Sciences and a point in the stack that makes the most sense for them. So when it comes to our customers that are developing cloud native applications that are microservices based, and perhaps are getting so complex that they need to start looking at solutions like service mesh to help with the security and visibility of microservices traffic, that kind of east-west traffic, service-to-service traffic. We've developed an integration with the Envoy proxy, which Istio is based off of, and essentially allows our agent to use the Envoy proxy as a module. So whereas previously, you would have a separate module component developed by Signal Sciences passing requests to the agent for decisioning. With the Envoy integration, the Envoy proxy itself behaves as the module. And with that, it enables development teams to secure their workloads and their microservices, regardless of where they're deployed. So, a kind of a new kind of fundamental change, I would say, in application security when it comes to cloud native applications is that you don't always know exactly where the workload's going to be deployed. And thus, a lot of organizations are moving to kind of more of a zero trust model. Whereas in the past, developers would only deploy it to, say, their on-premises hardware. And that would be set up in such a way that would be protected by a firewall, web application firewall, and so on. But now you have teams that are deploying to not just on-premises infrastructure, but also to multiple public clouds, let's say. And how do you ensure that regardless of where those services are deployed, they remain protected? So with our Istio and Envoy integration, our protection essentially is deployed alongside the application, so that no matter if it's deployed to an on-premise server or to AWS or Azure or Google Cloud, Signal Sciences goes along with the code and protects it no matter where it's hosted.
Now, I'm curious too, because you mentioned, I want to go back a little bit. You mentioned that east-west traffic, that sort of service to service. And there's also, of course, north-south, the sort of the traditional kind of traffic direction from the internet into a web application. When we're looking at those, or when you're looking at those and talking with customers, do you see different, perhaps, threats coming in for those? Or are there different ways they actually have to approach and consider what the security problems may be from this so-called east-west traffic versus the north-south traffic?
Yeah, absolutely. So we've definitely seen a rise of interest amongst our customers to protect against threats like server-side request forgery, which of course was the technique used in the Capital One breach, where a malicious payload was sent north-south, but ultimately it was in that request being passed on to like a tertiary service in AWS that resulted in certain secrets being compromised. So whereas in the past, all the focus was really on ensuring that traffic coming from outside of the application into the application was protected and malicious requests were blocked. Now we're seeing that certain requests that are meant to compromise an application aren't necessarily compromising the application itself, but perhaps some service that is then being called by the application. So as you have these complex web applications being broken out into microservices, whereas before, if it was a monolithic architecture, you could kind of ensure that all the communications was trusted because it was all occurring within the monolith. Now you have services talking to other services, and these services might be hosted on different infrastructure platforms and so on. So how do you ensure that traffic is also secured? Because if let's say a single node in the cluster, your Kubernetes cluster gets compromised, that could be used as a jump-off point to compromise other nodes in that cluster. And because that's happening all behind the traditional application perimeter, those might be attacks that you are blind to. So having that east-west visibility, east-west security is something that we are starting to see more of an interest in amongst our customers.
Yeah, I guess that's interesting and ties strongly into what you're describing, that idea of zero trust within the product space, the product application security aspect. I'm kind of curious too, because we have been talking about service mesh, this type of east-west deployment. You're talking about breaking up a monolith into microservices. But I'm also curious too, have you seen organizations do that successfully? And if so, what are the type of organizations doing this? Because I am curious too that there's a lot of desire to perhaps break up a monolith, adopt a service mesh because perhaps it sounds fancy new or because it has some more concrete benefits. But it's, again, one of those easier things to say than it perhaps is to do.
Yeah, absolutely. Microservices aren't going to be the best architecture for all cases. It really kind of depends on what the needs are of the organization and kind of what the application's function is. I would say that we've seen customers, break their monoliths into microservices, perhaps because they wanted to create fewer dependencies amongst feature teams. So by having an application, let's say if it's an e-commerce application broken out into microservices, then you can have, let's say, one feature team working on the reviews microservice and another feature team working on the product catalog service. And they're able to operate and develop at their own pace with fewer dependencies and fewer likelihood of kind of conflicts arising when those two pieces of code are integrated into the overall application. So that's certainly a benefit of microservices, but the drawback that we're also seeing is just the additional complexity, which at times can beget more complexity, right? So you have an application that's broken down into microservices, and now you're not exactly sure, okay, where did that request actually end up? Did it end up at this microservice or that microservice? And the lack of traceability is, of course, one of the problems that service meshes like Istio has been designed to solve, as well as kind of like layer 3, layer 4 security and network segmentation, kind of having policies created so that only certain microservices can talk to other microservices. Mm-hmm. But what we've seen is that these service mesh technologies, although they do a great job of creating that kind of security policy, they don't really do anything at the layer 7, in terms of like OS POP 10 and that sort of thing. So that's where we saw an opportunity for us to work more closely or integrate more closely with those technologies to bring that layer 7 protection and visibility to microservices-based applications.
So with those conversations then, we've been talking about developer experience from the very beginning, but I'm kind of curious, when or what role does the security team play in here? Whether it's these conversations about, this service to service layer 7 inspection and the same concerns about injection attacks, so to speak, or are they really just looking to see, or I guess I should phrase it this way, are you hearing from the developers who want these types of capabilities themselves, but they want to be able to do it in a way that is amenable to how they build and deploy software? In other words, they're feeling the responsibility and they're looking for solutions, or how much of it is still security team driving these types of capabilities?
Yeah, that's a great question. Actually, I had a conversation recently with a customer, and the person who I was speaking to is he's actually kind of more of an SRE, if you will, than a security team member. And he was the one that was really driving the conversation in terms of the need for east-west visibility and security. So I think there's actually some kind of like a bidirectional sort of conversation and education that needs to occur, because the security team may not be completely aware of the architectures being utilized in the applications that they are responsible for securing and protecting. And at times they just may not be aware that, there are these potential risks involved because the development team has decided to go to a microservices-based architecture. So I think what we're seeing is that it's more the developer side that are kind of, because inherently they do care about security, although, the myth has long been that, developers don't care about security. I think that's something that's patently untrue. And it's really just a matter of communication and having a culture where security and development teams aren't so heavily siloed, and there can be an easy exchange of ideas between developers and security teams. Because again, the security team may not be completely or have 100% visibility into what the application teams are doing, and such. It kind of rests somewhat on the application developers' shoulders to kind of bring up these concerns to the security team, and the security team will work with their vendors to figure out how can they actually implement these protections.
Alfred, my guess is a lot of security teams don't have a clue what's going on with the architecture of the application. So I think it's interesting that you're seeing the SRE team. Is that a replacement for what was traditionally kind of the architecture team? Site reliability engineering is kind of that new evolution of architecture and managing these complex applications going forward on the dev side of the house?
Well, in this particular customer, this SRE, he has become involved with Signal Sciences because he ultimately has to manage and monitor the health of the agents that they use to protect their web applications. But in doing so, I think that's kind of how he became sort of more familiar with how the development teams were building their applications and where these agents were being deployed. So would the SR team, is it always going to be the case that the SR team is going to be pushing for these changes? I would say it kind of depends on sort of the maturity of the organization. But oftentimes, I would say, like in these more forward-thinking DevOps organizations, you do see that close collaboration, of course, with developers and SREs, and thus I think it'll be the SRE, but at times I've also seen the architect for sure, because the architect really should have kind of the full visibility of what's going on there.
Yeah, it was an interesting use case, right? Because we've been talking about site reliability engineering as kind of this new way to think about these applications, right? But to have the security conversation come from the SRE is actually a very interesting use case, because they have to understand the complexity of that application. They're also in a really interesting position, I think, to also understand some of the potential aspects from a security perspective. Does security start to come under the SRE organization in the future?
Right.
Because these are the guys that are trying to make sure everything's running reliably in production.
Yes, absolutely. I mean, I think for the SREs, their primary responsibility, of course, is going to be reliability and performance, right? I mean, that's in their title. But security is also a very critical part of their job. So, for example, at Signal Sciences, a lot of times when it comes to just like auditing the IAM roles in AWS and ensuring that we don't have any roles sitting around that are being unused and don't have and have more permissions than they really should. These are things that our SREs are actually spotting and bringing up. So it's although it may not be the primary responsibility of the job, I'm finding that like they have the visibility and the curiosity to say like, hey, is that configured correctly? Do we have the right protections in the right places?
Yeah, I like that. Go ahead, John.
Sorry, I was just thinking it's an interesting way to think about this too, because I think historically, and it's funny because we're going to talk a little bit about this in the news, I think, but historically we've looked at, as security folks, we've been trying to get into those initial design meetings with the developers. And sort of what you're saying in a way is, I know you're thinking SRE, but it's almost either SRE or dev, if I can put those two into one bucket for a second, and say they're demanding the security people to be in the room with them so that they have more understanding of what's going on.
Yeah, absolutely. Because it's oftentimes the security team will have invested in a number of products that are already in use, and it may be from working with those products or just or coming up with these new use cases, and sharing them with the security team, that the security team realizes, oh, like perhaps the products that we have don't really kind of fit the needs of our organization because our needs have changed. So, I think, at Signal Sciences, like a lot of our customers are kind of on the more sort of forward-thinking end of the spectrum, and we are seeing a lot of that close collaboration between security teams and development or SRE teams. But it's still something that I think that perhaps in the enterprise is something that's still kind of evolving and still there's some opportunity there. When it comes to though, like the when you have that collaboration and that communication, I think there's just more trust, and ultimately it's just kind of win-win. Security team, they get more visibility into the potential areas in which there are vulnerabilities that they didn't know existed, and the development team and the SRE teams get to deliver on a product that ultimately doesn't just work better, but is more secure and ensures that that the end users are protected and the company is protected.
Yeah, and I wanted to add, I really liked how the direction this was going to talk about, and you mentioned too, the SRE's concern about the health of the application. And health definitely, I think, could have an umbrella of security, resiliency, availability, of that CIA triad, something we actually talked about last week. So I'm curious do, are they also looking for capabilities for features of something like Signal Sciences to give them more feedback about the health of the application beyond just an injection attack, a SQL injection or something like that? And instead, they could look at availability or rate limiting even, or these types of scenarios that are pretty important to the health, the uptime, and performance of applications.
Yeah, that's interesting you mentioned that, because we do have some customers who do use Signal Sciences for what would be more traditional like application performance management use cases. It's really because boils down to like how our solution is architected, and the fact that because we're essentially in line of the request, and we get that request before it actually hits the workload or the application. We can give these performance teams, these reliability teams, insight or visibility into like 404s or other 400 errors before their APM solution can. So although that's not necessarily our kind of primary objective as a security company, it was one of the sort of the nice benefits, I guess, of how we were architected. That we can provide additional visibility and show that there's an issue perhaps a bit faster than a traditional APM would.
That's pretty cool, because hopefully the narrative that emerges there is not the security team saying, hey, just go put this security device in front of your application because we need to tick a checkbox. But it's more of, guess what? You'll actually get some benefits about some basic performance, some basic engineering important metrics that come from, just so happens, this particular security solution. So to me, that sounds like a really great way for modern security products to try to aim for, to design themselves for. And I think, Matt, I stepped on something you were going to say.
Yeah, I mean, because of the rate limiting capabilities that Signal Sciences has in the platform as well. Think about this, right? You can see which endpoints are being hit via APIs, where potential abuses. These all have a potential performance impact and a security impact. And that's why I think it's interesting to have not only the security capabilities that you do, but some of that performance data is actually very relevant to the application teams, the SRE teams, for example. And so I can see that crossover being very relevant for people who are thinking that way.
Mm-hmm. Absolutely. Yeah, I think it kind of goes back to Mike's comment about security being a part of quality, right?
Mm-hmm. And so speaking of, I just trying to come up with a good segue for security and quality, but maybe I'll just turn it around to, as we go back, we started talking about Azure App Services, so making things easier for developers, especially if they're wrangling legacy software, try to make their lives easier. Any final thoughts or comments, or advice for developers moving into an Azure App Service or trying to deal just with legacy applications in general?
I would say that, web application firewalls, don't think of like web application protection as primarily like a networking security concern, which has traditionally been, where WAF has kind of been owned, I guess, in the past. There are newer innovations, newer technologies being developed to protect applications or workloads that will work with your existing development workflow. And this actually also kind of benefits the network team in a way, because if you deploy your WAF or your web protection at the application layer, then that is kind of one less component, I guess you can say, from the overall networking architecture that could potentially fail or break or cause issues. So when we were pilot testing our Azure App Service site extension, a customer had mentioned that they love the ability of being able to deploy the app level protection with the application, because it was one less thing that they needed to troubleshoot when they ran into issues, which previously they were deploying WAF as kind of more as a gateway. within their network architecture. And now, since it's deployed on the application, if they're seeing some issue, perhaps a request is not making it to the application for some reason, they're able to easily count out or discount Signal Sciences, because they can just simply turn it off at the application layer rather than taking out something in the whole request flow in their networking architecture.
Oh. Well, you've definitely taken us out on a journey through the cardinal directions of cloud environments. So I want to say thank you for this chat, Alfred.
Oh, thank you. It's really great talking to you guys.
Also want to thank Matt and John, and thank all of you for listening. To learn more about Signal Sciences, visit securityweekly.com/Signal Sciences. We'll take a quick break now and return with news of the week.
Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at securityweekly.com/Signal Sciences. In a fast-paced tech environment, the potential attack surface increases with each release and new app created. Detectify automates cutting-edge knowledge from trusted ethical hackers into the development pipeline for reliable application security. Go beyond the OWASP Top 10. Check your web apps for over 2,000 known vulnerabilities actively exploited in the wild, monitor subdomains for potential takeovers, and remediate security issues in staging and production. Learn more with a free trial at securityweekly.com/Detectify. Go hack yourself. By connecting to your code repository, Actrix generates a topology across your full stack to reveal risks so that you can harden your architecture. It also scans code for violations against compliance and security standards to enforce best practices. In addition, Accurix develops threat models using vulnerability feeds, IAM privileges, and other data to predict potential breach paths. Learn how easy it is to get started with Accurix at securityweekly.com/Accurix.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Security Weekly, in partnership with Cyber Risk Alliance, is excited to present Security Weekly Unlocked on December 10th, 2020. This one-day virtual event wraps up with the 15th anniversary edition of Paul's Security Weekly live on YouTube. Visit securityweekly.com/unlocked to view the agenda and register for free. In our webcast on November 5th, we'll show you how to build proper metrics and KPIs. On November 12th, learn why you should stop trying to discover and classify data. Then, in our November 19th technical training, learn how to thwart attackers using deception. Visit securityweekly.com/webcasts to see what we have coming up, or visit securityweekly.com/on-demand to view our previously recorded webcasts. And before we get into news of this week, I got a great some chat feedback from about our security theater presentation that we kind of touched on a little bit last episode. And JLK in the chat thought we should talk about it some more. So I thought that was great to hear from a listener. And John, maybe you could tell us what you thought about that particular presentation.
That guy, man. Yeah. So it's I like to think that I'm always living, eating, breathing AppSec and hopefully some other things too. But I didn't get around to watching this presentation until after the show last week. And, it rang enough bells with me that I felt bad of just pointing out what company Kelly worked with instead of actually having a decent conversation about it. So I said, hey, let's bring this back. So it's an interesting talk. And I think, I almost asked our last guest, but I didn't want to put him on the spot. So I should have preloaded it before we went on air, but I think there's a conversation here worth having about this. I think she brings up a lot of interesting points. I think some of it is it can be taken a little negative. So what I'm trying to do personally is take a step back, take a deep breath, and go, okay, take the negative feedback, and then ask the question of, does this actually relate to me and the AppSec projects which I've run and have been a part of, or where can I improve, or where is this just something maybe for other people? Or so that's sort of where my head is run up. I think it's worth more than the 20-second blow off. So curious to hear if Mike or Matt, if you guys have any deeper thoughts in, or I can pick out a few key thoughts from some of her slides and we can go from there.
Yeah, well, there's some great lines in here, and I think to your point, they may seem negative, but I think we can turn them into a very productive conversation. Look, our industry is full of marketing FUD. It is, just in general, right? And so you hear the term shift left a lot. And she has a great line in here. Shift left is often more shift friction earlier than build in security by design. It's a very interesting take. Now, developers don't want that friction earlier, but if I can get it out of the way earlier in the process, it makes me a little more efficient on the back end of the process instead of piling all this up at the end. It's just a very interesting take on the concept of shift left. I thought it was a really interesting one. Her second one, which is right after that, is DevSecOps. I'm not a regular security theater. I'm a cool security theater. Well, of course, because this term DevSecOps has been debated around and batted around for a while, is can sec really sit in the middle of dev and ops or not, right? And so I do like some of the things she states in here as ways for us to think about it outside of its marketing terminology and how other people use it to really understand, is it worthwhile to shift left? Is DevSecOps something we really can do, or are we just blowing smoke across over to the security team? I thought those two lines were very interesting.
Yeah, I think. Yeah. Well, go ahead, Mike, if you have something.
Now, I was going to say the things that stood out to me were really that aspect that Matt was touching on, and that idea of, are we shifting left, which really just means we're shifting the burden of security off of the security team more onto developers, Or are we actually, that's the negative aspect. That's the thing that we should be avoiding. That's sort of that theater aspect in the sense of, well, here's an activity that we should be doing because we've always been doing it, or someone has been doing it. And rather than the security team do it, we're just going to scale up and make the developers do it. But let's pause for a second and say, why should we be doing this particular process? Or why should we be switching this burden onto developers and instead do that aspect of, and I think you even mentioned this a little bit in the last segment there, John, what about the security involved with the design discussions? Because I think very strongly that security can just be an emergent process of well-designed DevOps approach or just an SRE approach. And we don't need to try and sneak that sec suffix or sec into there anywhere in order to just say, yes, we're part of the team. We can actually be part of the team by making life easier for developers to find vulnerability. So that's the part I really wanted to get up on my stage and talk about. So back over to you, John.
Hot potato catch. So yeah, and I think if I sort of try to put a few thoughts on what you guys are saying there, to me, a word is a word. And, some folks out there know I have a tendency to swear like a sailor sometimes, if not worse. But a word is a word. A word adds context and color and meaning around what you're doing. So, it's like I hope I don't make people cringe when I say this, but it's like when we have people saying containers have been around since the 1970s. No shit. But how containers are being used today is a little bit different than how they've been used over the last 20, 30 years, right? So, and then something like this, when I was doing talks, and hopefully again I'll do talks on stages, when we lighten up and get our health back in normal. But one of my things I like to say is, you don't go to a store and buy DevOps off a shelf, right? It's a word, and same with DevSecOps. There's a lot of people out there that really makes them cringe. I use the phrase DevSecOps because it's talking, at least to me, about a frame of mind, right? Can I mix security in with the developer process and actually have those things come closer together? And that's what I mean when I say shift left. Can we capture those issues earlier in the stream? So I think, and I'm not saying she's off base. I know there's a lot of folks out there, and there's a line in here she uses, which I saw at Layered Insight all the time, which is, if your company is putting a firewall on a container, that's security theater. Completely agree with her. But I think it's not so much active actors. I think it's people who are, in many cases, stumbling and just trying to figure out, how do we make this thing secure? Because they're trying to keep up with what's going on out there. So I think the talk is really good from a point of view of, like I said, take a step back and think: does this describe your organization? Does this describe what you're doing? Or are you doing things with a little more presence and purpose? And then she goes a little further down later about security chaos engineering. I was talking about this with someone last week, and I can't remember who, but their comment was, chaos engineering, the only group that I would trust on the planet doing chaos engineering is Netflix. So, and I think she's using the phrase to be a little more about, hey, let's learn and let's understand and let's have a feedback loop going on, right? Don't just do things because you can. If you can improve upon something and make it better, let's do that. So I think that aspect of things is cool. And again, it's how you take the words and what you think of it. But I think it's definitely worth people to at least read the deck and think about it.
I think it's a great deck for security folks to really understand the movement that is here and how they adapt to the movement, and not play their traditional, well, I'm the security team, I'm the security team of no, and you can't do this, blah, 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 right? I mean, this is great for security teams to really understand what's actually happening on the other side, and really, I hope, change the way they approach application security in this new world. Forget about the terms. It's about communication. It's about being adaptable. It's allowing you to figure out how to get the results without all the friction and all the complication that we've had in the past. So I think it's really good for security teams to just hear this and see this, because I think it will put them in a better position.
Yeah, why are we doing this, right? Thinking about, again, our last guest, he was talking at the end there about Signal Sciences doesn't want WAF to be thought of as something that the network team runs. Completely agree. At a previous organization, if we meant to make a change to the WAF, that would take days. And that completely is like that organization was talking about, were DevSecOps. or we're DevOps, or whatever, pick the phrase. But you go from that to like, oh, we need to have this multiple process to actually. So I understand, and this is real world and actually happens out there, and I think that's as I said, something for people to think about. And why are you doing things?
Why are you doing things? And I think that's a great thing too, that I also try to pull in when we talk about other articles, is sort of figure out what is a fundamental, what's something we can learn from them. Because one of the aspects too is, you mentioned if you're dropping a firewall on a container, or if you're dropping a lot of security tooling on a container, but then you're executing with root privileges, you're kind of defeating the purpose of that's sort of the idea of security theater, in the sense of, are we addressing the most prominent threat in our threat model? Are we doing something just out of inertia because we think it's a good process to have, and we think that we should always have a dual control and two people to approve something? But are we actually just approving for the sake of a firewall change because we need to approve firewall changes, but we're still letting everything through 443, and all the injection attacks, RCEs and path traversals, my favorite, can still happen through there. So it's one of those things that hopefully when we do talk about other articles, talk about vulnerabilities, we try to highlight what's good about, or what should a good reaction be, or how can we turn that into, call it a pre-mortem exercise or a threat modeling. And in that vein, sort of try to segue that into another thing we talked about last week, which was industrial IoT. And in this case, there was a news article about what are they? Industrial systems for irrigation that were passwordless by default. And that's kind of definitely a snooze almost, and just kind of roll your eyes like, passwordless yet again on IoT. But one of my questions there would be, who deployed this, and why didn't they have a run book that covered how to change and do password rotation, let alone from that initial install? So that's where I think that there is, that's not necessarily security theater, but there is still an important burden, important responsibility for this, both on the manufacturer in this case, of a pretty consequential problem for irrigation systems, as well as who should have been paying attention to say, oh, wait, we should have a new password on here.
I just want to get to the next article. Yeah, I'm not going there. I want this. I just this Flash article is like, oh my gosh, finally, hallelujah.
I was trying to find really quickly who the manufacturer is to see if they do. I want to see if my point from last week about the Siemens installer is the same thing, and if there's someone actually installing it, or if it's a company. But the point still stands, right? It shouldn't have default passwords. We know how to do these things nowadays. It'll probably take a few years for that to trickle out to some of the, I'll say, legacy companies. But anyways, everyone's excited about the next article, so I'll shut up.
Everyone's excited. Yes, I do have to say, because I can't give up my Halloween theme, and so for those of you out there thinking of industrial as music for your IoT speakers, every day is Halloween. And otherwise, if you're placing industrial systems on your IoT, please do something better with passwords. But that also means we can do something better about Flash now. And now there's a particularly important aspect to this about Flash being dead, that possibly, also speaking of horror movies, it may in fact stay dead. But Matt, you sounded pretty excited to get onto this. So what was your take here?
Well, the first thing that comes into my mind is ding dong, the witch is dead, right? Look at how many issues we've had with Adobe and Flash over the years, the vulnerabilities, the 0 days, all this stuff. And to see it coming to end of life, and then Microsoft says, yeah, I'm going to remove it and you can't undo it, is like, yes, exactly. Finally.
Now we just have to get people to. Now we just have to get people to apply the Windows patches.
Right.
Absolutely, and that's the part. If you're going to kill Flash, this is absolutely the right way to do it, because their guidance says after you install this update, you basically have to roll back or reinstall from a fresh instance without this update to use Flash ever again. So to me, that just sounds like, to John's point, we have to get people to install one more patch, please. But once they do, that pretty much guarantees Flash is dead. So that to me sounds like a great way to really enforce the end of the decomposition end of the software life cycle, which might also be decommission, but decomposition sounds better.
Right. And I think the timing of this announcement is about right. it means you've got about 65 days to apply the patch, which is probably the normal patching cycle for most organizations.
I mean, it'd be interesting as a thought experiment. Does the legal team at Adobe do anything about this? Did they? I don't remember if they yelled at Apple when Apple said we're getting rid of this Flash thing. But I mean, to forcibly remove another company's product from your operating system. And I know it's being shut down, so it's like I said, it's more of a thought experiment at this point. But that's in a way, it's sort of an aggressive move.
We have seen that, and there were even talking about, I can't remember, my sense of time is gone, but even if you recall the Zoom installer, Apple actually blocked that the old version of the Zoom installer, the one that installed a local a local host, web server essentially. So there is some precedent for that, and it is an interesting thought experiment to go through in the sense of, is this software introducing something that is a risk and a threat to the safety, privacy of people's data on their system? In this case, Flash, pretty demonstrably yes. And of course, as you mentioned, hopefully, I think the Adobe legal team is sitting back and drinking some champagne now that they don't have to write up so many breach notices or critical updates about Flash. So hopefully that's a good thing. But speaking of breach notices, go ahead.
Yeah, 1 second. Microsoft was doing this experiment themselves with the whole IE removal and forcing you to Edge. That was last week or the week before. So again, it's interesting when it's somebody else's product, but in Microsoft's case, they're doing it to their own product. They're like killing IE to move to Edge, say, look, we're not supporting it anymore, which also has a very interesting potential ramification for a lot of organizations that have still hung on to IE browsers. But what an announcement for Microsoft to make a very similar claim. Like, after this date, you can't use IE anymore.
That's a great point. And we've also seen even within the ecosystem, Google was one of the first movers to come out and say, we don't think these SHA-1 certificates are any good more for our TLS connection. So we're going to start to deprecate it. And then Firefox got on, Apple and Microsoft got on the bandwagon as well. And they did actually have to extend when officially those SHA-1 certs were going to die. But that was a movement that, a browser vendor started to impact the whole ecosystem. And so it is interesting to see how some pretty meaningful movement are being made here, and not without a little bit of pain or a little bit of objection either, I have to say. But I think now we can also talk about a breach. In this case, it was a Home Depot breach, and I can't remember what the amount of records were. But the aspect that stood out to me here was this was not a breach that was due to a external compromise, external actor. And even Alfred last segment mentioned the now notorious, infamous, if you will, Capital One breach, SSF into a S3 bucket. So external attacker, perhaps with some insider knowledge, but still a compromise. Nor was this was a cloud misconfiguration in the sense of a Elasticsearch or an S3 bucket being open. This was I'll kind of hand wavy as it was described as a system error, but basically, personal information being emailed, receipts, order information to the wrong people. And that is still a breach, for all intents and purposes, that the code itself was induced. So one of those things to keep in mind when you're having, as a security team, threat modeling exercises or discussions with developers about what are we building and what could go wrong. What could go wrong could, in fact, lead to emails going to the wrong people, leading to possibly a breach that requires notification.
Yeah, it looked like at least 900. And the other just little trick out of this one is also, if you're going to send to a bunch of people, put them on the BCC line so they can't see the other person's email address. I'm just saying.
Between BCC and don't reply all, those are the that, and we're going to throw that on our top 10 list of don't run as root and look out for .. So we're building our Application Security Weekly top 10. We'll have it finished by the end of the year. But I also wanted to shift. So we have been talking a lot about we started off talking about security theater and ways of asking ourselves as a security industry, are we doing the right things? Are we the baddies, so to speak? But rather than just focus on vulnerabilities, it's also want to focus on tools and how can we build better architectures. Here is an example, a new discussion or a new release from AWS and Nitro instances. And John, I know this came across your radar. Want to talk us through this?
Yeah, this is a fun one. And as you said, so I think the three big cloud providers now all have some offering in trusted compute. I think Microsoft got theirs out. Do they? I presume they do by now. So the question then comes like, what do you do? How do you do with this? And how do you make these things secure and trustable, right? So with Amazon's I'm butchering this intro. With Amazon's Nitro offering, what they're doing here is they've come out with a, the headline that captured me, I think, was from the Register, basically saying you've got a VM with no persistent disk, with no public internet access, and you can't connect into it. What the hell do you do with this? My paraphrase. But really, it's what they're doing is they're providing an air-gapped instance, which I think is sort of interesting. And it must have taken a pretty good amount of actually engineering on their part to do this. So the way this works with their child's Nitro instances, so it's actually, you create it from an existing Nitro instance. So you have, so basically, here's your run plane. You create an instance, an EC2 Nitro instance at Amazon. You hop in there with your Nitro tool set. You say, hey, I want to take this image, which could be either a Docker image or a VM image or whatever else. I want to turn that into a Nitro child. From that point forward, it's going to sign the boot image, sign the processes in there, and sign one other thing I forget. There's a few things it signs for attestation. It fires it up. The only way you can connect with that child interest is over child. Speaking today again, Mondays. The only way you can connect into that child instance is over a socket, a Unix socket. So that sort of limits you and is going to require you to think about a different way of how to actually connect this and do things with it. But the idea is if you actually need something to be securely computed, to use that phrase, this is Amazon's sort of choice in how to do it. So it's going to take a little more work. They've got some sample example code sets out there on how to play with it and how to set it up. But it's going to be interesting to see what people actually do with this, right? So it's you want isolation, there you go. If you want full isolation, now you go and you rent a full server from Amazon, so you make sure there's no other customers on the same box with you, and then you start doing this. That sounds pretty secure. With the attestation, what they've done is you're able to, as that instance boots, it can go out to the KMS, their key management server, and ask for the keys to decrypt whatever it's doing, either data or processes or what have you. So it will, at that point, attest the signs with the signatures which it used from during the compute before. So if those match up, you can say, okay, I've got a child instance, my signatures match. Let's go ahead and grab that data over that pipe, unencrypted with the key, do the crunchy, and then send it back. And so that's going to be their solution. It took a while for me to explain that because it's not a super simple thing, but that's how they're doing this. So I'm curious to see how people use it and how popular it becomes.
Yeah, I think it's a great explanation to describe that this is if you really need and want that trusted boot process, so that that image and that application that you start up, it hasn't been tampered with, so then you can actually then go and do have it secure computed, to use our phrase of the day, on your data. That is a very nice that's a very nice guarantee. And one of the things here too is this is also a long time coming. So as I mentioned too, we talked about like browser isolation. It took Firefox around 2 years, I think, from start to finish to actually get that deployed. Amazon announced, Nitro and this capability back in 2017, and they were playing around with basically how do we abstract the device model so that we can actually have these, encapsulated images and have them cryptographically signed, etc. But they realized doing it in software only is high latency, so low performance. And now they've switched to doing a lot of this within ASICs. And now those ASICs have produced the high performance and low latency capabilities. So not only can we get a trusted boot, but we can get a trusted boot that's going to do this secure computed data operations in a way that's actually not going to be too expensive, either in time or money. So I think that's a really interesting thing too, to watch that journey and see how a lot of these abstractions now are going into chips. And maybe we'll also see changes there with a lot of like Apple moving to a lot of ARM and I think Microsoft doing a lot of things with ARM as well, and even just building up custom ASICs for their cloud environments.
Yeah, the economics of this have really shifted the game when you think about the scale these guys are working on and their ability to first it was create their, I think Google first started doing, just use motherboards without a case for cooling processes and things like that. Just, get rid of stuff we don't need. And now these guys are creating their own chips, their own ASICs. It's sort of incredible what some of these large cloud providers are able to do now. So hopefully we'll benefit from that from a security point of view.
Hopefully we shall.
So. Let's hope.
Because we still need to benefit from that, because there's still going to be, as we were reminded in the last segment, there's still a lot of application layer, a lot of layer 7 vulnerabilities that secure computing, or confidential computing, I should say, isn't going to protect us from. So you can still have a very well trusted boot sequence and an untampered application that still has an injection problem, or in this case, perhaps an insecure way that it handles link previews. And I highlighted this particular blog post. It's a really nice overview of different considerations, different approaches to handling link previews, whether you're in a chat app, a messaging app like Signal or iMessage, or even something like Slack, or our very favorite Discord that hopefully everyone is active on right now during our live stream. But the point here is that I think this type of concern can be generalized to, are you an application handling user-generated content, and how are you rendering that? Are you rendering links on your own services or on the end user's device? Because there's a lot of interesting privacy and security trade-offs between exposing not only IP address or perhaps other cookies even associated with those users, to as well as, is this user-generated content even safe? Is it an image, for example, notoriously going after some type of flaw, an unpatched flaw in an image decoder?
Yeah, I'm looking at these different tests because, we use a couple of these, right? Discord will download up to 15 meg of any kind of file, right? Then you've got Hangouts, which we don't really use. Slack is up to 50 meg of any file. Zoom 30 meg. So yeah, it's interesting from a security perspective of how far this stuff can get before you realize, oops.
I think for many years we've talked about phishing attacks, and the RSA has tons of vendors doing the anti-phishing stuff. I think we're still on the edge of what we're going to see with the chat stuff. As these type of programs become more common for larger enterprises, we've talked at least once previously this year about different attacks you can do over GIFs and stuff like that are being rendered. So I think it's from 2 points of view. The 4 approaches they have here, 0, 1, 2, and 3. Are interesting. I think it's worth thinking about, and they've got a chart further down this page. It's a long post, but they've got a chart here that sort of lays out the different chat programs and how they do this. So you can sort of quickly look and see which one's yours and how things are going to, how your security is looking like right now. But I think going forward, we're going to see more of this. I get the funny feeling we're if these guys don't really hop on top of this, the bigger names, we're going to be talking more about this in the future.
We will, and it's great. Yeah, we have mentioned a lot of different image-based attacks, anything from just buffer overruns to denial of service. An exploding decompression algorithm, for example. And what was really interesting here too is also there's that privacy angle, and this happens to also pull in interesting design discussions I'll say the shift left in the sense of our architecture discussions when we're talking about end-to-end encryption. Because if you're going to say we're going to have strong end-to-end encryption, then by that very nature, you potentially are saying you actually need to now generate that link preview on the end client because you don't want to expose or leak any information about this communication, or Do you just opt in, have the user be able to opt into that particular decision, sort of like what Signal's design does? So there's really interesting trade-offs here just that are also impacted by what are the features or guarantees you're trying to make within your application beyond that initial security guarantee that you're not going to be exploited by an RCE in a particular decoder algorithm. So I think fun conversations can come out of that. Additionally, I think some fun conversations as we wrap up here. I threw in another link just since we haven't had a good architectural or educational, article in a while. Just a link with titled "Getting Started in macOS Security" that pulls in a lot of different training resources, blog posts, a lot of different people that are working in the macOS environment, from the iOS to now iPadOS, tvOS, and of course on our laptops and desktops, the macOS itself. So hopefully some good reading there, some interesting reading for those of you who want to dive into those particular angles of security. And I think too, there's one final article that I didn't throw into show notes yet, but I'll have to add that I think will let you take us out on. John, what was your one from this morning?
Yeah, one last final one. Sorry, they're trying to drag us off stage here. So this was from the Register also. Always fond of reading that, but briefly, someone figured out that you're able to do cross-site scripting through registering a company name in the UK business database. So apparently, it's actually legislated the characters which can and cannot be included in those company names. So they have a bit of a struggle to figure out how do they actually protect this, because they can't just easily filter out some of those characters. So now they're going to have to put up with a bunch of people having a little bit too much fun with cross-site scripting in company names for a while.
Exactly. And for all of you also playing with, for example, license plate readers who've been putting SQL injection, if you have been trying your cross-site scripting on your license plate reader as well, for those of you who don't live in UK to take advantage of this for real estate, maybe that's another venue to go after. But on that note, thank you for the entertainment about XSS. It's sort of the Bitcoin of vulnerabilities, I suppose. I want to thank everyone for listening. I want to thank Matt and John once again for joining me. And we'll thank everyone for joining us, which I think I've said twice, but it's November. I just wanted to make sure we started off on a good note. Well, thank you again. We'll see you next week on Application Security Weekly.